Good afternoon. So today we're looking at the follow-up lesson to the Theorem of Pythagoras. This is lesson 2. So you had homework. The homework was dealing with the Pythagorean theorem on the exercise on page 165. You did numbers 1.1 to 1.10, not so? Yes. Right. So what did you get for number 1.1? 5. So mark your work quickly. Right. Number 1.2? 13. Number 1.3? 12. 1.4? 10. 1.5? 17. 1.6? 12. 1.7? 1.9. Okay, you don't round off, you write as 1.9. Okay. 1.8? 24. 1.9? Sorry? 6. Who got 6? Wrong. 36. Also wrong. 8.5 sounds more like it. Who got 8.5? Alright, what did you get for the last one? A? Number 1.10? You didn't get that one. Okay, so what I'm going to do is, since the last two were issues, I'm going to do those two quickly, okay? 1.9 and 1.10. So in question 1.9, you see that xy is also equal to 6. Why? Why is xy also equal to 6? Because it is given equal. It's given that xy is equal to yz. Not so? Remember, whatever is not on the diagram, we must state it. Okay, so there is 6. Now what do we say? We can apply the theorem of Pythagoras, which is y squared is equal to 6 squared plus hypotenuse squared is equal to sum of the other two sides squared. So it's going to be plus 6 squared. The reason? Pythagoras with angle y equals 90 degrees. Okay? So 6 squared is 36, plus 36 is 72. To get rid of the square, I square root both sides, you may introduce square root plus minus. But in this case it will only be plus because I will be referring to length. So y is equal to 6 root 2. Let me check the root of 72. 6 root 2. You press SD, standard to decimal. It's 8,5 or 8,49. So if this is in units, then this would be in units. Okay, that's centimeters, kilometers, and so on. You guys understand? So let's look at 1.10. In question 1.10, what is the length of AB now going to be? Going to be A or 10? A. Why is it going to be A? So AB is equal to AY? Because that's given. It's given that AB is equal to CB. So according to the theorem of Pythagoras, let's set this up, what would it be? 10 squared is equal to A squared plus A squared. Reason? Pythagoras, angle B equals 90 degrees. Any confusion there, people? What's A squared plus A squared? 2A squared. And 10 squared is 100. Now what do I do? Now what do we do? Divide by 2, yes. That cancels. So a squared is now equal to 50. Now what do we do? Square root. If I introduce square root plus minus, but it won't be plus minus here because I'll be talking about length, and length is never negative. So in other words, that is the square root of 50, which is 5 root 2. Standard to decimal, 7,07. 7,07 units. Yes. 1.1 or 1.1. Okay. Any confusion there, people? So I'm just going to cut the examples for today's lesson. Okay, so now we're looking at the example on page 163 or 164 there around. So in the previous video we did the other examples. There's on 3 here. Example 5 on page, what did I say? 163. No? It's actually 164. Page 164. Okay, my mistake. Don't be so violent with me. Okay, so the question says solve the unknown signs. So you're all able to do number 5, not so? Can you all do number 5? Yes, so do that quickly. I'll give you 2 minutes to sort that one out quickly. Yes, you can do it. Alright, so what do we get? This would be 2 squared is equal to 1.2 squared plus x squared. Reason? Pythagoras with angle Q equal 90 degrees. So what do we do now? We bring 1.2 squared over. What? We want to solve for x. So x squared is equal to 2 squared minus 1.2 squared. Or you could have said 4 minus 1,44. No? Both is correct. You put in a calculator 2 squared minus 1.2 squared. You 64 over 25 or 2,56. So x squared is equal to 2,56. So what do I do now? What do I do now? Square root. Both sides. So what is the square root of 2.56? 8 over 5 or 1.6. Who got that one right? Where did you go wrong? Yes. Square root. So what did you write?
I see the 1,2 before the mix. The
Yeah?
x 2 equal to 2.
So what did you write? Tell me what did you write?
I say 1,2
1,2?
is equal to, and then 2 from x.
X squared
Minus 2.
minus 2 squared. Like it?
Yeah.
And there's no square. But how did you get this? Because I remember when we start off, we always, the order is wrong completely. But importantly, what you must note here is that is your hypotenuse. Can you see that? So I started with the hypotenuse. Hypotenuse squared is equal to the sum of your other two sides squared. So if you always start off with this opening statement, you won't make that mistake easily. You understand? Right, next. You guys do number 6? Okay, I'll give you a chance to do number 6 now. Couple of minutes. You have 3 minutes to sort that one out. Okay. Okay. So when we start off in the sum, you say 8 squared is equal to 8 squared is equal to x squared plus 5 squared. Why? Pythagoras. The angle B equals 90 degrees. Okay. So what do I do now? Take the 5 over. So what do I get? 8 squared minus 5 squared is equal to x squared. Not so? So what is 8 squared minus 5 squared?
39.
Huh?
39.
39. Now what? Square root both sides. So x is equal to the square root of 39. Or square root of 39 gives you 6,24. Thank you. Okay, you guys understand? Any confusion? Or is it a surprise that you got it right? You say the tide is changing now, ne? You start getting things right. Right, this is number 7. Let's look at number 7. What makes number 7 different to the triangles that we've dealt with before? Two shapes. It's two triangles. Not so? So, could I have calculated the value of y first? No. Why not? Because of the tone of my voice? No. Huh? We don't have dB. Tapa.
No, so you don't have
Tapa. We don't have BD, which is x. Not so. So we have to first calculate dB before we can calculate y. We first need to solve for x before we can solve y. Because when we solve the unknown values in the previous calculations, there was just one unknown in the sum, or in the triangle. One side is unknown. However, here we have two sides that is unknown. Okay. That's unknown. Okay. Right, you guys understand? So we need to solve for x first and then y. Okay? So we start off, since there's more than one triangle here, we start off by naming the triangle we're working on. So we say in triangle ADB, or ABD, or BDA, or AD, and so on and so on. Okay? Do we have to say that? No. We don't have to say it, okay? But we say it so that we know what we're talking about, okay? The examiner can see that we know what we're doing. So as I said before, you don't have to say this, okay? It's in triangle ABD. So it's this triangle here. Okay? So you all agree you can apply Pythagoras there. Okay, that is simple. to solve for x. Once you got x, then you work in triangle DBC, and then you solve for y. Okay? I'll give you a couple of minutes to sort that out. Okay. So we said you're going to start off with x squared is equal to 12 squared plus 9 squared. Why? Pythagoras with angle A equals 90 degrees. Not so? Put in that calculator. (12 squared) plus 9 squared gives us 225. So x squared is equal to 225. The square root thereof 15. You all agree with that? So now I can use 15 in the other triangle. Okay? So what do I say now? In triangle BCD. So it's this triangle I'm working on. Okay? What can we say? Where's your hypotenuse now? 25 is your hypotenuse. You can see it's opposite the 90 degrees. Okay? So it's going to be 25 squared equals y squared plus 15 squared. Why? Pythagoras. I can call it angle D, but there's many angles at D. That one, and this one. So there's more than one angle at D. So I have to name it properly. It's going to be C DB or DBC. One of the two. Okay, you all agree with that? Alright. Here we go. DEC. No, not DBC, but BDC. Equals 90 degrees. Remember, if I'm going to say DBC, then I'm referring to that angle there. That's why the order, the angle we're referring to must be in the middle. You understand? Alright, do you guys understand? So, this is going to give us 25 squared minus 15 squared is equal to y squared. Not so? So work that out. 400. So how do I get y on its own? Square root both sides. So y is equal to 20. Okay, is there any issues that you guys had? Any problems? Mistakes you made? You all got it right? Okay, good. Let's look at number 8. In number 8, could I say, to solve for x, could I say in triangle EGD, that x squared equals 17 squared plus 12 squared? Could I have said that? You say you don't know. What do you think, Leah? Huh? Could I say that? Why? It doesn't have it? Right, there we go. For us to apply this this had to be a right angle triangle. Remember by definition that your hypotenuse squared, for your theorem of Pythagoras, it says in any right angle triangle. So that is not a right angle triangle. And we can't just assume it's a right angle either. It must be given to us or we have to prove it. So since that is not a right angle triangle, I then in turn cannot calculate x in that triangle GDE. Makes sense? Right. So now taking a step back, x is actually the hypotenuse of this big triangle here. Not so? But according to Pythagoras now, your hypotenuse squared, which is x squared, equals, what is this length? 20. Not so, 12 plus 8 is 20. So x squared plus, x squared is equal to 20 squared plus fe squared. But hang on, this is also an unknown here. There are two unknowns in that triangle. Not so? So could I apply Pythagoras as it is there? No. What do I need to calculate first? EF. EF needs to be calculated first. Okay? Let's take this color out here. Okay, how can we calculate EF first? So hang on. EFG is also a right angle triangle. Not so? So here I can now say 17 squared is equal to 8 squared plus EF all squared. You see now that is your unknown. Yes, Walia? So you're asking, must we put a variable in there? You don't need a variable, you can just call it FE or EF. Does that make sense? See any other questions? So you all know how to calculate EF at this point. Once I got EF, then I can cover this big triangle here. And then calculate X. Does it make sense? Yes. So I'll give you a couple of minutes to sort that out. I want to keep you after school, man. Okay, now I can carry on. Okay. Right, so we're going to need to calculate EF first. So we say in triangle. If you did not say this, it's fine. In triangle FGE, we're going to say that this is your hypotenuse. So we say 17 squared equals 8 squared plus FE squared. And where are we getting that from? Pythagoras. With angle F equal 90 degrees. So we got 17 squared minus 8 squared is equal to FE squared. So FE squared is equal to, yes, what's the question? EF squared is the same as FE squared. So it's going to be 17 squared minus 8 squared. 225. You getting it right, you say? I'm proud of you, no? Right, so how do you do now? Square root. If you had just worked from the beginning of the year, you would have got it all right. But okay, rather now than never, no? Right, gives you 15. There we go, 15. Okay? Relax. So what do we do now? In a big triangle we can work on now. In triangle FDE. You see there? There's your 90 degrees. Okay? So in triangle FDE, what do we say? X squared equals 20 squared plus 15 squared. Your reason there is Pythagoras with angle F equal 90 degrees. You all okay with that? Yes?
You get the 20 because you plus the 8 and 12.
8 and 12 is going to give you 20. So 20 squared plus 15 squared, 625. You all okay with that? 625. And the square root of 625 is 25. Okay, any confusion there, people? No? Just when you get the same sum in the exam, it's a different story, no? You're not going to get it right if you're not going to practice the work.
No, sir, I am practicing.
You am practicing.
So there was mention of saying a book in the Pythagoras.
Oh yes, yes, that's from you guys, you people. But you're watching the videos now. Now you're not watching Netflix anymore. You still watch Netflix. Okay. We just did that one. I want to do another one, man, before the bell ring. No more shame. Poor us. Alright, so that now brings us to the end of the examples. So for tomorrow, for homework, we have 5 minutes left. So we can do 5 sums in this time. I'm joking. 2 sums, yeah. Right, so for homework, I want you guys to do number 1.11, 12, 13, 14, as you can see here. That's the last of the single triangles. The 1.14, yes. And then you do for me 2.1 to 2.6 on page 166. Okay. You know, you must always be excited to do your maths homework, not only now. No?
So math is only fun and you understand it.
All the time, Michael. But if you didn't understand it initially, you had to tell me you don't understand. No? Right. Then, yes, Walia said must do some probability. Right, so let's stop this video. And then perimeter and probability.